Yes, sir.
Shall we proceed, sir?
Yes, sir. Sir, Karthikeyan, sir.
Yeah.
Good afternoon, sir.
Good afternoon, sir.
Rahul sir, சொல்லுங்க sir. Good afternoon,
Shall we
sir.
start?
Sir, you can start.
Okay, sir.
Yeah. So very good
Okay.
afternoon, one and all. Most respected chief guest, resource person of Optimum session, Dr.Sankar Ganesh, Dept of ECE, School of Electrical Engineering, Electronics Engineering, VIT Vellore, and very good afternoon all for second session. Karthikeyan sir, you can proceed.
Sir, I am audible, sir.
Yes, sir, audible.
Yes, sir. You please continue, sir.
Okay. Very good afternoon to one and all gathered here. I am SS Karthikeyan, Assistant Professor, Department of EEE, Dr. NGP Institute of Technology, Coimbatore. On behalf of Dr. NGP Institute of Technology, I would like to thank our management, our principal sir, HOD sir, my dear faculty friends, and faculties from various institutions to conduct this wonderful AICT sponsored Phase 3 online STPP on machine learning and IoT for industrial application. Chief guest introduction. Dr. S. Sankar Ganesh, Assistant Professor, Senior Grade 1, Department of Communication Engineering, School of Electronics Engineering, VIT Vellore. He completed his bachelor degree, BE Electronics and Communication Engineering in the year 2002 in Manonmaniam Sundarnar University. And he completed his master degree, Computer and Communication Engineering in the year 2008 in Anna University, Chennai. And completed his PhD in the year 2019 in the field of machine learning in VIT. He has 18 years of academic experience, and also he published research papers in reputed journals, and also he published book chapters like Handbook of Research on Fuzzy and Rough Set Theory in Organizational Decision Making, Chapter 13, Optimized Fuzzy Logic Based Bit Loading Algorithms. And also he completed his consultancy projects, prepared and handled a module on image processing for engineers in KP IT Technology Bangalore from 21/12/2015 to 23/12/2015 and from 28/12/2015. And he is a member of IEEE and also ISTE, and also he acts as the resource person in various events like seminar, workshops, conference. Session is yours.
Thank you, sir. Thank you all. Am I audible?
Okay. Audible, sir.
Okay. So first of all, let me thank the Dr. NGP Institute of Technology Management for providing an opportunity to share my experience in this AICT sponsored third phase online short-term training program on machine learning and IoT for industrial applications. I think I am one of the resource person, so I'm just going to handle my session on the topic machine learning for IoT. Yeah, I think this is one heading where we are covering the two broad areas, so the machine learning and IoT. So first of all, if you check the title, machine learning and IoT for industrial applications, so that we can have, so the organizer have correctly segregated these three terms. If you could see from the session, the 28 to 30, and then 1 to 3, the second part, so you can get the glimpse of machine learning, Internet of Things, as well as the industrial application. So few speakers would be talking about how these are implemented and then the few speaker will be talking about what are the current industrial application where they are using machine learning as well as Internet of Things. So my part, so in this 90-minute session, so what I am going to recollect or just to share my experience or share my thought on machine learning for IoT. So when you are talking about this ML and IoT, so these are the two keywords. Other than that, we will be having artificial intelligence, ML, and then deep learning also. So I'll just brief it later. What is the difference between AI, ML, and then DL, or what is the nexus connecting AI, ML, and IoT? Let me tell. Clear. So first of all, when you are talking about Internet of Things, so this will transform our life significantly. So our day-to-day gadgets, what we call it as a smart devices like laptops, smartphones, tablets, whichever we are using, so that will interpret our verbal script. So whatever we are talking into any languages, or it can respond to our semantical queries, and then it will be aiding our support in our day-to-day life. So this IoT may be covering either not either. So physical devices, our home appliances, our vehicles, and then whatever the devices which we call it as a smart, everything it will be connecting with IoT. Or then we will have some things, what we call this Internet of Things like embedded with sensors, actuators, gateways, and then different software modules. Everything will be communicating with each other and then interpret data, and it is supporting our day-to-day life. So when we are talking about the surveillance, suppose for example we are having a robot, so it will do the multiple tasks such as in entertainment, and then it will surveil our homes against any hazard and so on, so many things. So it is not intended for particular application. So though it was designed for particular application, but we can use it for other aspect also. Clear. So the same thing finally we'll have the wearable electronics. So why I'm just doing this, so this is the third phase. So few topics or few technological terms, if you remember with respect to IoT, it will be easier for me to continue further for this session. Clear. So whenever we are talking about Internet of Things, so the three key aspects we should know, that is anybody can access, anywhere it can be accessed, and anytime it can be accessed. So these are the key, what we call the takeaways of IoT. And then there are so many other definitions are there. They are interconnection via the Internet of computing devices embedded in everyday object. And then we can call it as data is everything and everywhere. So IoT can also be defined as the analysis of data to generate a meaningful action triggered subsequently from our response or from our request. So that is just an interchange of data. But the scope of IoT is not just limited to getting the devices connected or network, but it is about the exchange of meaningful information from one device to another for the particular action. So that is also very, very important. So the data, you can call it as a king or a queen. In fact, the data is everything. So why I'm just particularly talking about the data is, nowadays the data is anything. So previously we used to for collecting the data we should toil hard for collecting such data, and nowadays we are all the data producer than the data what we consume. So what you can say is, suppose for example, if you want to check the price of a particular item in an e-commerce website, what you will do? You will put it in the Google. So this is the item I need. Then immediately all the e-com retail outlets websites will be coming, and then we can check the price. So whenever we are just checking the price, it's like a data producing. So what is our interest? What is our desire? And what is the thing which we are fond of? Everything we are just giving them with this feed. Then wherever you go, just to close that browser, you just open it again. Wherever you go, you will be getting that. So whatever we searched, so that item will be popping out. Be it whatever the gadget you are having, or if you are checked about the room availability. So everything, it will just pop out that we have received an offer for this, you search this item. Otherwise, the same thing, the common meme we used to check is customer who bought this also brought that. So these are all the things which we are giving the data. So we are all the data producer. So in the earlier days, it's very difficult for us to gather the data, but now the data is everything. So why I'm just particularly talking about the data is, so this is an every minute. If we are surfing or if we are browsing via internet, so these are all the data which we are getting. So nearly in a minute of day, it's in 2019, but you can check it in 2020. It would be either leaping in, would have been two folds considering this pandemic situation. So most of us are meeting or just connected through online. So many data will be having. So we will be having some orders received or some live streaming, and then how many of them connected via MS Teams and so many other things. So the data is everywhere and everything. The data is all. So that is what we will be having. So whenever I'm talking about the data, so how these data are produced or how we are collecting this data. So those data are collected with respect to IoT devices. So whichever you are using. So whatever you have. So if it is smart, when can we call it as a smart? So if you are using that adjective to a particular person, so he is a smart person. Suppose if somebody is telling he is a smart person, so what we will think is, so he will think out of the box. So we'll call it as, otherwise we will do it in a day and he would have been doing it in a half a day. Or we will take that much effort, and with little effort he let me do it. So that's what we call it as we want to work smart, not hard. So those are all the things. So that adjective we are giving it to a device. So what is the meaning is you have, so we are surrounded with so many gadgets. So now how I am meeting you, so visual. So this is also a smart gadget. And then there are so many. So what are the enterprises involved in this? So I'm having a mobile phone, then through that I'm just connected to a Wi-Fi. Then I think I'm using a mic jack, I'm using a headphone. And then how are we connected? Through a common platform. So I am in southernmost part. So throughout India, few of the press audience would be there. How are we connected? What are the enterprises it is there? So everything, it is interconnected. So all data. So whatever we are up to that, it's everywhere. The starting point, we'll call it as the data. So these data, that is very much important for the IoT devices. So previously, before 10 years, nobody would have thought that IoT will be growing in leaps and bounds by year 2020. They would have predicted, but still there is no assurance. But now, what are we going to get? So what is the current IoT market? So that you can have. So nowadays, I think we will be having, so we will have 24.1 billion devices by the year 2030. And see the amount of data which we can collect. So presently in 2019, I think to 7.6, and then if 2020, it may be around 8.3. So it is going to increase, or it going to what we call triple by another 10 years. So that's what. So in that, 34% of the devices will be media devices, 14% for smart grid, and then 7% for autonomous vehicle, 16% for home appliances, 4% for tracking, which we can use it for whether the product is there or available, and then 2% for inventory management. So that you can see. And then even the media devices alone, it is going to have the huge impact. And then how these devices are interconnected. So all these devices should be interconnected. All these devices should be connected through a common communication protocol. so that we can have a proper exchange of data within those devices. And then depending on that, we will be having a short range communication, private networks and public networks. So if you could see that orange color, so most of the devices in among the 24.1 billion, 17.4 billion devices are going to use only short range communication. So the huge impact and huge the content for the research are there for this Internet of Things. So for that only, how are what are the challenges posed by Internet of Things, and then how ML can aid the IoT for solving that, and then vice versa. So both the ways we can check. So in that aspect only, with this starting point, I'm just going to take around this session under the topic machine learning for IoT. Okay, so what is machine learning? So how I have split it is, I'm just given the preamble to IoT, and then another few slides, 10 or 15 slides, I'll just cover up the machine learning algorithms without any touch upon the IoT. Then I will connect IoT and ML, and then at last I can give what are the applications of IoT with respect to machine learning, and then what are the machine learning algorithms are currently used for each and every challenges posed by IoT. So in that aspect, I am just going to cover up this lecture. So machine learning is just how it is the mimic of our learning process. So how we think upon, how we act upon, how we respond to the particular query. So that is mimicked by a machine learning. Clear. So the same thing, suppose for example, if I am giving you a photograph of your family members, you can easily identify the pattern. How are we going to how we identify those persons? When we look upon them, so immediately we will think about that he is my cousin, so I played with him, I watched movie, then we will play a sport together. Likewise, some known pattern, we will immediately it will strike our nervous system, and the brain immediately identifies that this is the person we know. So the same concept, you can use it for your group photograph. So the 60 people will be there in your class. So after 4 years, so I'm just talking with respect to Bachelor of Engineering and Bachelor of Technology. After 4 years, I'm showing the photograph and identifying all the 60 of you, whether you could do it. Few will do, and then few we cannot. Then after 5 years, so the number will be significantly reduced. After 20 years, we hardly remember 1 or 2 unless and until we keep on in touch. So whatever the pattern which we could identify with those person in the next year or next month, immediately after you pass out of that particular college, the same we cannot sustainably doing it for the longer period. So for that we need a machine. And similarly, if I am asking you to multiply 2 numbers, you will immediately tell. I am giving you 2-digit number, you will immediately multiply. 3-digit number, somewhat difficult. 4-digit, it will take some time. 6-digit, it will take more time. 10 digits, it will be very difficult for us to find the product. So what will you do? We will use the calculator. Suppose, for example, I am just giving you 2 floating point number. You cannot do it in calculator. We will write the MATLAB code. So what you can do, whatever the process, whatever the logic we used for 2 and 2, the same applicable for the numbers which I have given. So what we fail is if we cannot do it for larger data. So for the longer time, larger data. So those are the key aspect why we are having the machine learning. So we cannot do the same process which we can do it for the which we did it for the smaller volume, that we cannot extend for the larger volume of data. And then whatever the task we did it for the stipulated time, for particular time, we cannot extensively do it for longer period of duration. So those key aspect only we are having this machine learning. So this will enable us to do it for larger data as well as the simpler task for longer time. So this is a cross-disciplinary research, so where we will be using, or we need the expertise of computer science, statistics, and then how are we going to approximate the different function, optimization, control theory, decision theory, and then computational complexity, as well as the experimentation, how we are going to run those algorithms for particular data. So everything which we need. Clear. So when we are talking about AI, ML, NN, DL, AI stands for artificial intelligence, ML stands for machine learning, and then neural network and deep learning. So this is a nexus we keep on. Suppose, for example, had it been the title is artificial intelligence for IoT, it sounds good. And then if I am telling machine learning for IoT, that is different. If I am telling neural network for IoT, it pertain to particular machine learning algorithm, that is neural network. If I am telling deep learning for IoT, then it is narrowed down to only deep learning algorithms. So ultimately what we are trying to do is we are going to going towards the artificial intelligence. So machine learning is subset of artificial intelligence. With the machine learning algorithms, we are going to cover up the artificial intelligence, or with the machine learning, we are going to extend it to artificial intelligence in a device. And similarly, neural network is one of the machine learning algorithm, and deep learning is a subset of machine learning. So this will give you so that if you could read AI, ML, NN, DL, you will come to know what is what. So ultimately, ML, NN, DL, all we are using it to achieve artificial intelligence for the machine, which we are going to take it up. And similarly, and for here, IoT applications, for IoT devices, what we are going to do. So those all the devices, if it is connected via internet, what are the devices, how are we going to store the data, and how are we going to retrieve the data, and what is the data analytics we are going to do, how far that, what is the machine learning algorithm currently used. So that's what we are going to check it. So this will give you artificial intelligence, then we have machine learning, and then currently deep learning. So that is the common breakthrough we are having in this 2020s. Okay, so when we are talking about the learning, there are three types of learning. One is supervised learning, unsupervised learning, and third is reinforcement learning. So supervised learning is for structured data or labeled data, and then those labeled data already we know that what are the output and what is the output for particular input, and then we will be knowing the pairs of the pattern. So for each and every input, what is the corresponding output we can have. So the likewise we can do it. Suppose for example I want to classify three coin denominations. So we will have a cent, we will have a dirham, we will have a rupee. So each rupee, so I will take it as the minimum denomination of 1 dirham, 1 rupee, and 1 cent. So what is the key features with which I can identify this is a cent, this is a dirham, or this is a rupee? So first one is the size, and then second is weight. So those are all, we'll call it as the features. So with that features only, we are going to segregate them. What is the supervised learning? So now whatever the coin which we are giving, so it will be either classified as either a cent or rupee or a dirham, because it is supervised, means we decided the output. So the output will be one among a cent or a dirham or rupee. So that is supervised learning. So it is already labeled, so already decided. So for such type of learning, we will call it as supervised learning. Unsupervised learning means, better I will take it the example of a cricket. So I am just giving you 50 players. Okay, so 50 are cricket players. How are we going to classify? We don't know. I don't know. Previously in supervised learning, it's a labeled data. So I'm going to classify them, or I'm going to identify whether it is a cent or dirham or rupee. But in unsupervised learning, the example which I have taken, you know 50 players. How are we going to classify? Okay, so in that aspect, what I will do, so all cricket players, so what is their performance measure? Run score. Other performance measure, wickets taken. So the T2 performance measure I will take. So now I will just plot a graph for 50. So in the x-axis, I will take the player, in the y-axis I will take the what you call, or in the x-axis I'll take the number of runs scored, in the y-axis I'll take the number of wickets. So 50 dots will be there for each player. So now I can group them. Those who scored more runs, I'll call it them batsmen. Those who score more, those who have taken more wickets, I'll call them bowlers. Those who have taken runs and bowled wickets, I will call them all-rounder. Now, previously, I don't know whether they are all-rounder or batsman or bowling. So, only thing I am having a raw data, which is a 50 players. And then one idea, what is the hint I am having is they are all cricket players. So, now I classified them into batsmen, bowlers, and then all-rounders with the unique features. So, this is called as unsupervised. So, previously, they are labeled. It is a cent, it is a rupee, it is a dirham. And next, it is unsupervised learning. There is no classification. We don't know what output or what class they belong to. Only the raw data I am having. So this is the difference between supervised and unsupervised learning. So third is reinforcement learning. It's like depending on your action, you will be getting the reward by agent. So these are the keyword: agent, action, and reward. So the set of inputs which is aiding the process or which is enhancing the process performance, then agent will identify those input and then they will reward them as one of the data set or one of the features which we used for training. Suppose a set of input is hindering the performance process, then agent will reject those combination and then they will not be coming back for the next set of training. So this is what we will call it as reinforcement learning. So with the act upon or with the output, we will receive the feedback, and then depending on the feedback, it will be changed. So that is the responsibility of the agent to choose the particular action, and those actions should be properly rewarded. So that is what reinforcement learning is. And this one area, and still a lot of research is going on, is RL. That is reinforcement learning only. So you could see virtual reality. Then we change to augmented reality. So everything what we'll do is we will decide the next step. We will decide the next stage. So that is for that they will be using the reinforcement learning. And then one example you can do is, I think most of us will play the Candy Crush. Suppose each and every. So if I crossed to 60th level, my screen will be different, and if you have crossed 60th level 1 month back, and your task will be different. So how much we are crossing. So depending on that, they will keep on changing. So for that, they will be using the RL. So this is the very upcoming research area in machine learning, that is RL, reinforcement learning. So if there is a time, you just dig deep into this in the RL topic further. Okay, so there will be 11 branches of machine learning algorithms. So under each branches, we'll be having some another set or group of machine learning algorithms. So altogether comprisingly, I'm just going to list out. I'm not going to explain. I'm going to list out, and I'm going to tell the key feature or key aspect of each and every machine learning algorithm. So with that lead, I will just move to the machine learning algorithms for IoT application. I'll just move. So those 11 branches are deep learning, ensemble learning, and then neural networks, and then machine learning by regularization, rule-based, and then regression, Bayesian, decision tree, and then dimensional reduction, instance-based, and then clustering techniques. So here in IoT, I'll just brief it out, which are the algorithms most commonly used. So that will be one algorithm under these branches. So the most commonly used are deep learning, neural network, regression, clustering, and then decision tree, Bayesian. So those are all the algorithms. They are currently using it for solving particular challenge posed by IoT, Internet of Things. Clear? Okay. So this is the remaining algorithms. You can see. So if you could search the mind map of machine learning algorithm, you will get this picture. So it's not that I made or I grew up this tree. So you can just check it out. Suppose, for example, you could see this is the deep learning algorithms. So I'm just going to check it. So now you can see. So these are all, we'll call it as the deep learning algorithms. And now what you can say is these are all neural network algorithms. And so everything it is coming under machine learning algorithm. So altogether the 11 branches are there, and then we will be having the different things. Suppose for example, if I am using what we call back propagation, and this is the back propagation for IoT. So if this comes under neural network algorithm, we'll have a machine learning. So now you could see, so neural and then and what we call DL. So everything it is coming under machine learning algorithms only. So you could see the different features and what we can use it for the particular applications, so which we are going to take it out. Look, so RL we will not it's what we call as beyond our scope. So I'm just concentrating whichever the solution they have proposed, everything it is coming under supervised and unsupervised learning algorithm. Supervised for labeled data, unsupervised learning for unlabeled data, raw data, which we don't have any input output pattern specifically. So you could see, these are all. So under supervised learning we can classify, we can regression, and then we can cluster under unsupervised learning. So you could see neural network is, with the neural network you can do the classification, with the neural network you can find the regression equation and then for regression model, and then last for clustering also we are using the neural networks. So likewise so many other algorithms are there. So everything, some can do the classification, some will do used just to find the regression models, and some can be used for what you call the clustering also we can make use of it. Okay, so the main differences between classification and regression. So the classification is for discrete and regression for continuous. We'll call it as real valued output. Yes or no type, 1 or 0, binary classification. So yes, no, on, off, obese, not obese, obese, thin, thick, short, long, short, tall. For those we'll be calling it as classification. Suppose even if I want, if it is a obese, what is the weight? So for that we will use the regression. So KNN, K, nearest neighbor, decision trees, and then perception classifier, and then under regression we are having a linear regression, ridge regression, and then lasso regression. So the main difference between this classification and regression is classification is for discrete type, and then what you say for regression is a continuous values or real valued output. So for that only we will be having. So when we are talking it to further, what we want to do it for classification for this is, suppose for example if you want to, you have a sensor ready, I want to classify whether it is hot or cold. So I will do the classification, and the same sensor reading I want to check what is the reading of the sensor, a particular let it be a temperature sensor. So I want to know the temperature, accordingly I should act upon whether I want to turn on the AC or turn on the heater. So for that I need the real value of sensor data. For classification I need only the threshold. So if it is greater than the threshold, I will do this action. If it is lesser than the threshold, I will do the other action. So this is the classification and regression. So the first part is in machine learning, with which we can classify or we can find the regression. A regression, you can use regression to find the real value output. Okay, so what are the whatever the maybe the algorithms? So the 11 algorithms which I have which we have discussed before are under 11 algorithms. There are another 45 algorithms, 45 or 50 algorithms I listed out. So all are going to have the different functionality, but all has to be implemented with proper pipeline, what we call as steps. So these are all the 7 steps in any machine learning algorithm, be it any application which we are going to take it up. Suppose for example ML for computer vision, then ML for NLP, ML for communication, then ML for biomedical applications, and now ML for IoT. So these are all the topics you can have with respect to ML. So all these are connected with this 7 steps. So you be it for what you are going to do, and be it for what data which we are going to use it. So the machine learning algorithm is the common for commonality for all the applications or the topic whichever I have just mentioned before. So all those machine learning algorithms are going to use or have these 7 steps. The first one is data collection, and second is data pre-processing, and third is choosing the model, and fourth is training and testing or splitting the data for training, and then how we can going to evaluate the model, and then depending on the evaluation we want to have the hyperparameter tuning, and the last one, what is the way which we want, whether you want to do it for a prediction, whether you want to do for a forecasting, or you want to classify, or you want to recognize, or you want to identify something, that we are going to do it. So this gathering of data, data collection and data collating, so everything comes under the data. So as I told that data is everywhere, data is the oil, data is the king or queen. So without data we cannot proceed anything. So the first step, collection of raw data, is very important. It's like the similar way which we will be preparing for a particular course. Suppose I am just they have given me they have allotted a course. So suppose I'll take this HTTP program. So they have given me this topic nearly a month before. So what I did is Google. So I know I have some experience. So accordingly, I'll just fix upon. So what I will do is AUML for IoT. I'll search. So what I did is currently what are all the blocks, because these are all upcoming fields. You cannot see the updation in the textbooks. So the basic requirement and the basic foundation, we can read it from the textbook. But otherwise, the up to 10, what is the trend? So that we don't have any textbook, we should read the blocks. So many blocks are available. So just I will read it out and then I have noted out. Then I will search, I will put the same topic in YouTube. I'll get some videos. So whether it will be the implementation of IoT, and then what are the ML tools available for IoT, and then for a particular application, what is the machine learning algorithms are they used. Likewise, so many videos are there. So that will also I'll collect. Then I will just check it with the manuscript, what we call as journal publication. So whatever the topic, whatever the publication related to this ML and IoT I have collected, then I'll just go for the textbook I collected. So now I am having, these are all called as raw data. So what I am having is the presentation from my previous webinars, and then presentation about this topic. Then I am having some ebooks about this topic. Then I am having some blog reports about this topic. Then I am having some video tutorials about this topic. Next, what I will do, so whichever pertaining to the particular topic, and then whatever I can convey within those stipulated time, I'll just segregate. So I'll pick and choose few materials from each and everything. Then I will collate together. So what I did, first I gathered all the data. Then I cleaned. Clean the data means removing the unwanted data. I did it. Then I check for data integrity. What do you mean by data integrity? So what for particular source, which for those data, what is the source? So different sources will be there. In that I will just, because I cannot have a video link in this, so I have removed that. Then what I did, everything I converted now into a presentation form. So what I did ultimately, I reduced the data. So the data transformation. So first what I did is data cleaning, where I removed the unwanted data. Then I did the data integrity, that is each and every data from different sources I have segregated. Then I did that data transformation. I converted one form to another form, and then everything I have just converted into the PPT. Suppose for example, if this presentation is having some 100 slides, so it's difficult for me to go through the entire 100 slides. So what I did is dimensionality reduction, that is called as data reduction. So the data reduction, I am just doing it at the last stage, not at the first stage. So these are the 4 steps. We will be doing it for the first 2 steps. That is collecting data. Then in that I am having data cleaning, then data integration, that is data transformation, and data reduction, that is dimensionality reduction. So that is what. Now those data is good. Those data will directly will get into this webinar HTTP topic. So likewise, so the same thing we are going to do for particular application. So whatever the steps I have told, now the same you have to do. First you have to collect the raw data, then you do all the 4. So that is called as pre-processing of data. So with now what I told what I mentioned before is the data is the essential need, and the data is very much important for our next step. So now I am having the data. So with this data, now I want to check whether it is a labeled data, is a structured data, or unstructured data, or unlabeled data, or whether I need the feedback for this data, and then that can be changed, and everything I will analyze with respect to data. Then accordingly I have to choose a model, whether we are to go for supervised model or unsupervised model. So supervised, whether I want to do for classification or regression. Unsupervised, so clustering. So what type of clustering I have to do. So everything I will be taking care, and the third step I have to choose. I will be choosing a model, whether it is a supervised or unsupervised. Now also I have collected the data, I have chosen the model, then I want to check the training. So this is like what you have, it is in the class. Suppose for example in this semester you are having the 6 subjects mean, so every subject particular timetable you will be following. So throughout the semester of 15 weeks you will be taking the lecture, faculty or the course teacher will be taking the lecture for each day for the particular subject. You will be preparing on your own. So we'll be having some internal assessment. So for every internal assessment you will be having some 10 week or 3 weeks or 10 periods before. So likewise after every 10 hours of lecture you will be having some internal assessment. At last we will be having the semester examination. Likewise I will be splitting the data for training and which I want to do it for testing. So your timetable, the entire 15 weeks I have split it. So out of that 15 weeks, 12 weeks for lecture, 1 week for internal assessment 2, and then second week for revision, third week for internal assessment 2, and final week for semester examination. Likewise, then I have splitted the data. Now I will evaluate. So that is your examination. So depending on that, you will be evaluated, and then you will be preparing the same topic everyone, but the performance will be different depending on the person to person. Clear? And then whether you have achieved your target or whether you have achieved, what about your performance, whether you have reached your desired target. So that I will analyze, and then I will do the parameter tuning, and at last will give the semester examination. There you can go for the next step or anything else. So that we will be deciding. So the same step we'll be using it for machine learning. So once we will have a training. So this training and splitting of the data set is very important in machine learning algorithm. Be it any application. Suppose for example I'm having some 1000 data. So in that I will be using 80% for training, 20% for testing. So from the already known result, 80% I will be using it for training. Then 20% is the same model which I have trained with those 800 data. I will test for 20. Already I know what is the output of those 20, and with respect to our model, what is the output we are getting. I will do the comparison analysis or error analysis, so that I will be fine tuning the model. That is your parameter tuning, and then after that we will be fixing up the model. We will be doing it for a real-time testing, that is prediction or forecasting, classification, recognition, or identification will do. So these are the 7 steps which we will be doing it for most of the machine learning algorithm, be it any application. So now the fifth one, that's evaluation of our performance measure, or when we will have the stopping condition and everything, that will be decided on few factors. That we'll call it as ML model metrics. Clear? So the 2 challenges which we face with respect to ML model is overfitting and underfitting. And then those overfitting and underfitting problem can be avoided by another two methods, which is called as generalization and regularization using bias and variance. So these are all the key words you should remember for the machine learning models. And if you are not facing any problem like overfitting and underfitting, then correct fit, we'll call it as statistical fit. So the two challenges which we are facing, overfitting and underfitting, will lead to or will give to another two challenges, which is called as generalization and regularization, and that can be done via bias and variance. So when you are talking about overfitting and underfitting, it's like suppose for example, if you are going to a tailor for a stitched cloth, not ready-made. So the tailor used to take the measurement. Suppose for example, a shirt. The tailor used to measure the hand length, and then the tailor will check for the pocket length, and then shoulder length, shoulder breadth, and then shirt length. They will be doing it. Suppose what he doing is without training. So he want to take the shirt hand length. Instead, he is taking the leg length. What is the use? That will be just a number, but it is not going to do it. Suppose for example, if he is too strict on measurement, and then there will be the process, that will be a delay, that will be the error in the measurement. So these two challenges, what will do? Either it will not fit to us, the dress will not be fitting to us, or it will be overfitting for us. So both problem. So that's what we'll call it as. So we'll have a underfitting as well as the overfitting. So how we can be avoided underfitting is we have to increase the model complexity. So for shirt, we should have more measurement. Then we should increase the number of features. So collar length, shoulder breadth, front and back, pocket size, where it should be positioned, shirt length, and then from the length to hip, what is the size, everything it should know. And then remove noise from data. So instead of 2 inch, if he is putting 3 inch, or instead of 2 inch, if it is putting 1.5 inch, so there should not be a lot of noise. We should remove noise. Then instead of one measurement, we can do the 2 times. That is all called as increasing the number of epochs or increase the duration. So if these 4 are done, then the cloth will not be underfit. The same we can do it for a model also. To reduce the overfitting, so the same thing, increase the training data. So it should be more trained. Then reduce the model complexity. Instead of so many measurement, we should have the single measurement. And similarly, yearly stopping of training phase. So we need not to prolong the training. We'll have the up to what we need. We will stop at that point. So that's what a problem with overfitting. So underfitting and overfitting problem. So the two key word, there are two common word in those techniques for underfitting and overfitting is training data. That's what I told. So the training, the data which we have taken by collecting, we have what was the data we collected and what is the how we pre-processed. That data we'll call it as the training data, because that data has to be splitted into training and testing data. So that training data is very, very important. So that will give you this lot of challenge. Clear? So with respect to that, we will be having, so the next set will what we call it as the deep learning. Anyway, just to brief it out with respect to generalization and regularization. So the generalization means how quickly or how what is the ability of our model to generalize the particular pattern. Suppose for example, you have been attending the lecture. Okay, so in the examination there is a question which you wouldn't or having a numericals or problems which you have not solved that type in the class, but the knowledge for which that problem can be solved, that is instilled on you in the during the lecture. Okay, so few will not answer. Few would have been answered that, but you will not arrive at the correct solution. But few would have got the correct answer. So everything with respect to how you generalize those concept and arrive at the particular value. So in that aspect only we'll do. So the model also, suppose we have given a training for particular input. So without that input, if a new input comes or during the real time, then still with the ability which they have learned during the training phase, the model should be able to generalize the output for particular input. Then we'll call it as a generalization. So the regularization is the reverse part. So with those generalization and regularization, we can avoid overfitting and underfitting problem. Clear? And what we call the buzzword or most commonly used machine learning algorithm in this late years is deep learning. So the deep learning is a subset of machine learning, and then both machine learning and deep learning are progressing towards the concept of artificial intelligence in a particular thing. So whenever we are talking about a single layer, it's machine learning, and we call it as a multi-layer, we call it as deep learning. So it's a single dimension, multi-dimension will have the deep learning. So the three key factors which will differentiate ML and DL is big data, large amount of data, large volume of data, big model, not only with respect to one features, lot of features, and then computational complexity will also be higher. So this is extensively used in computer vision, speech processing, and NLP. So those are the very toughest application where we involves a lot of computation and a lot of data involved. So deep learning is extensively or most commonly used in this application, be it CV, speech processing, or NLP. Clear? So the same thing we can use it for IoT. When we are having an IoT infrastructure where the lot of devices are interconnected, then for that also we can use this deep learning rather than with some other machine learning. So in that concept also we can have some deep learning aspect. Clear? Okay. Now, what is the power of AI or ML in IoT? Why we need an AI and ML in IoT? So that is the second part. I am just coming into the picture. So most of the startups in this era, what you can say is in this decade, are either based on AI or ML or IoT. And then AI focus IoT startups are acquainted by other IT giants so quickly. So you can see. And so then they want to have a common platform. So that's vendors of IoT platform. So we are having Amazon, and then GE, IBM, Microsoft, Oracle, PTC, Salesforce, all are integrating AI capabilities. That is more or less ML and DL. And then they are in a situation that they are taken aback, or they will feel inferior that if they are not using any AI or ML services in their organization. So likewise, I think Gartner predicts by 2022 more than 80% of the enterprise IoT projects will include an AI component, and up from only 10% what we are using it. Another 2 years, it is going to increase by 80%. So you can check it. I think what is the most common skills of 2025 or 2022, and then what is the job opportunities for which what is the job market for current which engineer or which technical expertise needed for the next 5 years. So likewise, you can search it. More or less you will be getting a data engineer, data scientist, and everything. And then now you can have an ML engineer, AI engineer, ML architect, ML researcher, applied ML researcher, applied AI researcher in IoT. Likewise, you have the so many things. And then I don't know how many of you have heard about NASCOM. NASCOM, there will be, it's a skill development program by the central government. So there they are having some different certification. So you have to go through the classes, and then you have to give an examination. Then they will giving you the certificate. We'll call it as a NASCOM certified engineer on particular topic. So in that, the key skills, we are having IoT. They will be having IoT domain specialist and IoT fundamentals. So those are the two certification you have. Similarly, for data analytics, you have the separate certification. If there is a time, you just go through it. So that way also you can what you can feed the hunger for exploring the latest research opportunity that you can feed upon, so that you can do it. So ultimately, so everything in the most of the world, we are moving towards an AI focused IoT. So that's what so it is helping hands, AI helping IoT, and the IoT mutually benefited by AUML. So where most of the machine learning algorithms are coming into limelight because of this application. So that's what we'll have. So there is a trend in employing machine learning to improve the lot of IoT applications, like providing IoT services like traffic engineering, and then network management, security for IoT devices, internet traffic classification, which device has to be used first, and then quality of service optimization. So these are the key aspects there where we are having some lot of scope for AML. And similarly, so this, as we have discussed earlier, so it can eliminate human errors, so that we will train and then we will check it, and enable us to have the big data to generate real-time insights, and allows the Internet of Things devices to reach their full potential, even if it is a one or many. So we can collect the data from most of the devices as they are interconnected, and then we will be having these analysis. So for that, we need ML in competence to IoT. So when I am talking about the IoT challenges, I think these are the 4 challenges, what we call, that is unanimously accepted. Most of the blocks you can see are in any textbook. If you could see, I am not exploring about IoT opportunities. So other key speakers are the previous session you would have taken, but now I'm just concentrating on IoT challenges. For those challenges, how the machine learning algorithms can help. In that aspect, I'm just briefing it out. 4 challenges. One is security and privacy. Second is accuracy of operation. Third is volume, velocity, and variety. And fourth one is interconnectivity. Clear? So when I am talking about security and privacy, so in most of the time I am giving more stress on data. So, and then many devices should be connected via internet. So like many devices are connected via internet. Clear? So now rather than how much effort we are putting in connecting the devices and collecting the data, and the same impact or the same effort we should be taking care on their security and privacy. Clear? So I am telling that if we are searching for an item, immediately it will peep into the next social media platform. So that is our personal data. So we need not to be collected. Similarly, you are having some gadget, smart watches. Clear? So that will give us immediately, if we are having some what we call as, if your heart rate is more, immediately it will alarm through our mobile. So those are all the personal data which is collected by personal medical that is medical sensors. So how are we going to take care of those data? How the security and privacy can be maintained in those data? So that is the first challenge. Similarly, all the sensors will be interconnected. All the sensors may not be having a conducive environment. A few sensors would be implemented in harsh condition. So how the data sent from those extremely exposed sensors in the real-time application, whether we are going to get the correct data or faulty data, or how many times I am going to get the data. So those challenges also, it's very important. And third is volume of data, and the speed at which the velocity of the data, and then there will be the different sensors and the different gadgets. Even the embedded system also can be act as an IoT devices. So that the different format, different sources, how are we going to maintain these 3 V's? That is also posing a lot of changes for that, how the machine learning algorithms can be used, or what is the machine learning algorithm that can be implemented. Then last is interconnected. So we talked a lot about the lot of IoT devices, how each devices can be interconnected, how each device is going to send, or how the exchange of data is taking place about between the different enterprises to establish the IoT standard. So these are all the 4 challenges for that. There will be a lot of scope, or we can have so much solution through machine learning algorithms since it is adaptable. Okay, so why use machine learning algorithm for IoT? Because the volume of data is more, as well as we are having a lot of automation opportunity. And the next is the predictive analysis. I'll just take an use case. When a car is moving, so it's like autonomous vehicle. So the lot of sensors will be there. Each sensor will be recording thousands of data, which needs to be processed in real time to prevent the accident, as well as we want to properly choose the lane for the comfort of course, for the comfort of passengers. So as a human, it's very difficult for us to perform such a task for each and every car. So automation is the only solution. So each and every car is interconnected, and then we are going to have a common algorithm. Clear? So through ML, so the central computer of the vehicle can learn about dangerous situations like speed and friction parameters, and which will be dangerous to the driver, as well as it engaging safety systems on the spot. So this is with respect to what I am saying is volume of data and then automation opportunity. So we are having for this use cases, whatever I have taken, there is a scope for large volume of data, and of course there is a need for automation. Yeah. So for this use cases, I am definitely having a large scope for large volume of data, and then there is a need for automation opportunity. How this predictive analysis comes into picture for this use case? So immediately, so there is a you imagine a autonomous vehicle, there is driverless vehicle. So we are having a traffic light, we are having a fire hydrant, dehydrant, and then we are having a pedestrian, what we call as a pedestrian movers, and then a cyclist is there in front. 4 objects. So I have to detect all 4 objects. Then on the way go itself, I want to detect what are all the object, and which are the object is moving, which are the object will be stationary, and if the object is moving, what is the velocity with which it is moving. So everything will become random. So it's a predictive analysis, it cannot be certain. Clear? So for that, ML can be used with respect to predictive analysis. So this concept, volume of data and automation, it's needed, but the predictive analysis will have larger scope. Then only we can implement to the core of any application. Clear? So we'll call it as edge intelligence, this IoT. Clear? So because this IoT can be transformed, the data can be transformed, it can be analyzed, visualized, and then embedded across the entire ecosystems. That is edge devices, gateways, data storages, or in the fog or in the cloud, whatever you call, it's a cloud. So all the data we will be having it. So whenever we need the particular devices, they can draw, or they can hire, or they can buy, and then they can use it pertaining to the safety of particular personal data. So everything we'll call it as. So it is called as the edge intelligence. Clear? So it is at the each and every edge, the intelligence is incorporated. So that is the way we'll be having. So the key components of IoT, like mechanical and electrical parts, sensors, different processes, then storage and software, ports, antenna, and different communication protocols. Then onboard analytics to train and run AI, that call it as dashboard. So everything. So these are the key components of IoT. Clear. So when you are talking about the data, so these are the different way. So in some manuscript, they might have used what you call stream data. The stream data is live data, and then massive means at a time the data will be what you call there will be a flood of data. And then third is historical data. So it's all with respect to the timeline. We'll call it as massive, stream data, historical data. Historical data is past data for traffic prediction. So in the Google map you could have seen, so when you want to go when you enter the GPS location from and to if you enter the destination, it will give you the shortest route. And then after that, if you click on go direction, it will show the arrow mark. And then throughout our itinerary, we will have some yellow, green, red. Yellow, mild traffic; green, free; red, heavy traffic. So how those are identified? Those most of those red, green, yellow are based on the previous historical data. So previous time, during this daytime, past 1 month, what is the average traffic? So likewise they will be predicting. So that's what they will be using it as the predictive analysis. So now with respect to IoT data, we'll have a metadata. It's like I think most of us would have submitted a journal paper. In that they will ask for the metadata. It's like our name, our affiliations, and everything. And the student, if you want to create an email ID or create an account, they will ask for metadata. So likewise, IoT devices, the metadata corresponds to device ID, what is the class type, what is the model of the device, date of manufacture, whether it is hardware, if it is a hardware, what is the serial number, everything it will be having. Then state information, that is the current status of the device, whether it is a read or write. Then third is telemetry. That is read only about the environment, which will be usually collected through sensors. And then commands, that is the set of actions performed by a device. And then operational informations like whether it will be a temperature, if it is for how much temperature it can withstand, and then what are the breakages, that what are the action that leads to the breakage and how it will respond. It will be like what you call the data sheet for particular devices. So that will have the characteristics and everything about each and every devices. That extreme conditions also highlighted. So that aspect we will be having it. Clear? Okay. So this will give you the picture of the IoT. So anyway, I'll share it through the proper channel. Otherwise, you can check it, because what you can say, I'll just read out this. So the sector is IT and networks. So if it may be a public one or it may be an enterprise. And what are the function it is rendered by IoT is e-commerce, data centers, mobile carriers, fixed carriers, and internet service provider. And this is what we'll call it as the different apps, what we are going to use it. Similarly, you can check it the consumer and home appliances, infrastructure, and then awareness and safety, convenience and entertainment. So likewise, and the different enterprises they have given. So it is almost covering every sectors: buildings, energy, consumer, health, industrial, transportation, retail, and then security, and then IT and networks. So we'll have so many IoT use cases like smart building, then smart transportation, smart appliances, smart security, smart gadget. So everything, it will be coming under these enterprises. Okay, so most of the IoT use cases, how that can be analyzed. So maybe in other session we will be having, they will be throwing more light on each and every topic. Now, as the topic suggests, I will be checking it in the sixth one. So these are called as 6 key performance indicators. Or with this six topics, under this 6 topics, an IoT use case will be analyzed. Like what are all the IoT devices needed for that particular use case, and then how those IoT devices can be network interconnected and how they can interface. That is different. Networking is same type, connecting. Interfaces two different heterogeneous connection, so that we need. And then how are we going to collect the data, whether you are going to store it in a data warehouse or we are moving it to the cloud, and if you are moving it to the cloud, who can access those cloud, who can directly read the data, write the data, and how are we going to retrieve the data. That is called as data engineering. And then similarly, with respect to use cases, what are the key performance indicator for particular use cases? We'll have a display board, and then adaptive testing plan that we need, and then last is innovation and machine learning. So now you could see where we are going to use. So it is not like we are going to compulsorily use this machine learning. If an situation arises where we cannot do it for larger data, where a particular operation has to be done for longer time, we need this ML. That's what I just explained it before. So in that aspect, we are having so many tools. So you could see, so all the machine learning algorithms are already available. So just you have to use it. Azure, SageMaker, and then Amazon Web Service, IBM Watson, Google also we are having. So these are all the tools with respect to IoT we can directly use for larger data as well as for automation, and then we can do it the predictive analysis also. So that these tools, it's not free, but you can have a trial version and then have a glimpse about this. Clear? So where we started and which point we keep on emphasizing, that is called data. So the data characteristic can be big data, volume will be more, and then data quality and data usage. So if it is big data, I am going to check what is the volume of data, how many devices are there, and each device how much data we can collect. Then each device is falling under how many different formats, and last is how much data they are giving, velocity, that is with respect to time. So some sensors will have every second interval, some sensor every minute, every hour, every week, every month, so many are there, will do it. Then with respect to data quality, we want to check whether it is redundant or not. Then we want to check the accuracy of the data. Then dynamicity, how long it will be changing. And then granularity, fine change in the data quality. Because if you see, just giving you an example, suppose for example, you are having some pollutant measurement. If you check for carbon monoxide, it will be ranging it from 0 to 1. But if you are taking with respect to humidity and pressure, the data will be larger. So likewise the data quality. And then data usage, whether we want to check for logical error, semantic, or their completeness, whether you are going to check all the data is received. And then the next is noiseless, whether you want to check whether any anomalies or not, or that everything will be decreased. So all these, in then most of the topic we will be using the machine learning algorithm. So likewise big data, data quality, and data usage. So be it any supervised or unsupervised algorithm. So now you could see. So this is a paper. I have just given it in the reference. So 2 papers helped me in this concept very well. And then you can also start from, if you want to do the research or if you want to learn and explore more, the 2 papers which I have cited at the end of the presentation. Both the papers are survey papers which will give you an idea what are the current trend till 2019, how many authors have used what algorithms and everything that we can do it. So now you could see for k nearest neighbor, we'll do for classification. So these are all the machine learning algorithm, commonly used machine learning algorithm, and for that for what they have used, whether they have to use for classification or regression or feature extraction or dimensionality reduction or anomaly reduction. So all with respect to the previous thing which I want to take in. Suppose for example, I'll take okay, so I'll take the velocity. So the velocity of the data I can classify. So if it is giving the data every second or if it is giving every minute, so that I will take it. Suppose for example I want to check the semantic. For that I will use the feature extraction. So particular part of word is there, then this is different. If there is having a negative sense, it is different. So likewise, so we want to analyze accordingly, we will be acting upon this machine learning algorithms. Clear? So either we want to classify it, or we want to have a regression, or we want to have a feature extraction like this. Clear? And similarly, so that's what I told. So smart, these are all the smart city uses smart traffic, and then for that we need classification. For classification, you can use any machine learning algorithms. And similarly, for smart traffic and smart health, we need clustering. And then for smart traffic, smart environment, we need anomaly detection. And then where we can use SVR, support vector regression. And similarly for smart citizen, which we don't have any black mark, for that we will use k nearest neighbor. And similarly for monitoring public places, we need a PCA. And then then canonical correlation analysis also we can use. So these we will call it as the branches. So everything we can use. So for depending on your use cases, the particular machine learning algorithms what we can already use we can do. Similarly, this is very important. Smart agriculture, till now they are using only naive based classifier. And for what? Food safety, passenger travel pattern, estimate the number of nodes, so everything. So this will give you an ample idea about what is the machine learning algorithm for currently used for smart city cases. So when we are talking about the industrial application with respect to IoT, and for that how ML is useful, like traffic profiling, IoT device identification, or simply we'll call it as device identification, then device security, then personal health and industrial, and then last one is edge computing. So for all the thing, what are the machine learning algorithms? So that you can check it out here. So these are all the machine learning algorithms. So the classification means, and the classification you have 4 or 5 machine learning algorithms, you can use it. So for this 5, how it is going to take it? Suppose for example, this is for traffic profiling, and this is for device identification. Okay, so these are all the input. Then what are we going to take? What are the feature vectors? And then what is the machine learning algorithms we can use? How the machine learning algorithm can be used, or what is the machine learning algorithm used? And then application of this traffic profiling. So that will go. So the input may be a data from a backbone network or wireless network or mobile network. So what we'll have is a dump data will be there, and then flow extraction can be given or split it into a data capture as well as the flow extraction. From that, we will be using a clustering or Bayes classification, and the application leads to traffic patterns, traffic engineering, app identification, security intelligence, and then different application will have the same thing. If the network changes, and then the same thing, we will be having sensor data, feature extraction. Then I can use this machine learning algorithm, and then I can identify the device number, or what is the type of device, whether it's a mobile or whether it is a network device or whether it's an IoT devices. So likewise, you can do it for the security as well as edge computing. So these are all the input, and what is the analysis we want to do, and then what is the machine learning algorithm you can use it for this application, and then excuse me. So for intrusion detection, whether we are having intrusion or not, or anomaly detection, any unauthorized user is there, privacy, who can be the access, then who can read or write the data or change the data. For that, we will be using the machine learning algorithms like ANN, SVM based network, decision tree, and K-means. Similarly, for edge computing, the same type, image recognition, traffic engineering into. For that, we can use any clustering algorithm, Bayesian or deep learning and Markov model machine learning algorithms can also be used with respect to these applications. Okay, so the challenges posted by IoT, and for that, what is the machine learning algorithms that can be used? I'm not telling that how it can be used. I'm just briefed out the supervised algorithm, and then what are the 11 branches we can use. Similarly, we can check it for the other algorithms also. Clear. And this is with respect to the last one, that is application with respect to personal and human health. So for that, we can use the decision tree, logistic regression, SVM, Markov model based network clustering, then random forest. Those machine learning algorithm we can use. Certainly, they will be using the data capture. What they will capture from the data is vital signs, environment data, and then how they will do the data processes, feature extraction, and then those are the 4 application we can have. Okay, so this will these questions are still unanswered, so you can have if there is any scope, you can start from this scratch. So saving computer resources, I have told so many IoT devices, but still all the data has to be stored and everything. Unstructured data format, so adding devices by million and billion in the year, so the data format will be different. How we are going to make it structured, or how are we going to analyze this unstructured data format will be a real challenge. And then real time and online analysis.
Participants, please mute your audio so that you can reach out. Sir, sorry for the disturbance.
Okay, sir. So real time and then online analysis. It's like you just think the complexity, or then you what you call how immediately we want to act upon with respect to driverless vehicle. Immediately within a second, it should be taking it. That we should collect the data, we should analyze the data, visualize, and immediately we should act upon. So these are the 3 open issues. Still, the lot of research scopes are there, so you can try it. I think almost I just came to the end of my presentation. So these are all the sources I have told. So especially I want to highlight these 2 papers. So that will be I found extremely helpful in organizing this presentation, because that is a survey paper which will give you instead of referring so many other papers, that will give you the current date, because these are all updated till 2018 and then already implemented and then recognized by a body. So in blocks, it's more or less is at a current trend. So it's a mixture of both. We want to take it further. So I don't know how you will be having so many questions, whether they have answered or not. And most probably this type of virtual meeting or a short-term training program, you find it in a way that you can ask more questions to you and find the answer, rather than finding the answer from the program. So that is my kind advice. So here few topic or few words you might be hearing it for the first time. So immediately you note it down, then how can be used, that you just correlate and then keep up your learning spirit. Anyway, thank you all. So this is my personal mail ID. So if you need any help or any suggestion, so you think that I am just worthy enough, you can send a mail to me. Definitely I will reply back. Thank you.
Thank you so much, sir. There are questions in chat box, sir.
Okay, sir.
Rahul, sir.
Yes, sir. One by one, I will read it out, sir. Sir, first question, sir. from machine learning, can we expect pattern of raw data?
Sir Rahul sir, once again, sir.
Yes, sir. From machine learning, can we expect pattern of raw data?
Yeah, if you want to start analyzing the raw data, definitely we should identify the pattern. So with the machine learning, we should identify the pattern. Then only it will generalize. It will give the proper output.
Sir, then they are asking about any hands-on session can you give, sir? Software simulation for a software simulation of IoT.
That you have to answer, sir.
Okay, sir. Okay, next question, sir. What is Internet of Everything, IoE?
Yeah, that nice question. Clear. Suppose, for example, if I am talking about only smart devices, so that is Internet of Things. You just imagine. So it's like a sci-fi film. You just close your eyes and imagine. So you are in a car. So many that scenes have been already taken in 007 films. There is a car. You don't have a driver. You are not having a driver in the car. So the car is taking a proper path. Then immediately, so it will give. So all the vehicles are interconnected. So that will be calling it as Internet of Vehicle. Suppose each and every buildings, that is also becoming smart. Each and every object, that is also becoming smart. So my car is an entity. Now that is smart car, smart object, smart building, that is everywhere it's connected. So that's what's called as Internet of Everything. So Internet of Things, Internet of Vehicles. Now whichever the things which we are seeing, that has become smart. So we'll call it as Internet of Everything world.
Okay, sir. Sir, next question, sir. What is the difference between a wireless sensor network and the Internet of Things networks?
No, if we are taking a wireless sensor networks, if it is not interconnected via any the short range communication, if we are taking only the dynamic reading of that sensor, then we'll not call it as Internet of Things. So if all those WSN wireless sensor networks are interconnected via internet and that can be communicated with each other devices, then we'll call it as Internet of Things. So the question is, WSN can also be considered as IoT if it is properly networked and connected to other WSN network. That's it.
Okay, sir. Thanks, sir. We move to next question, sir. What are the tools IDLE used to realize the ML learning?
Now, so many are there. I don't know whether the person wants to know or not. Now what it call is, it's like a text editor. So many are there. PyCharm is there, Spider is there, Anaconda is there, Tawny is there. I am using Jupyter Network and PyCharm. So the PyCharm is most commonly used. So we cannot say that this is the best and everything, because most of the IDLE tools are connected by open source platform, that is Python. So whichever the library which can be taken or which can be used, we will be using it. Other than that, only the simulation environment that will change.
Thank you, sir. These are the questions that we found in chat box, sir. The session is more informative and educative, sir. You explained what is happening, elaborated and in a lucid way. Thank you very much, sir.
Thank you.
The questions that
Dear participants, if it is any questions or any clarification, can unmute yourself. We can directly interact with our resource person. Sir will be patient to answer all the questions.
Sir, my question is, sir, can you hear
Yes,
me?
sir. Yes.
Yes, sir.
Yeah.
Sir, my question is, I'm working on machine learning. My research area is character recognition. I'm working on pattern recognition. So my field is handwritten character recognition. My topic is Urdu handwritten character recognition. My question is, sir, which tool should I prefer? Shall I use convolution neural network to perform this character recognition, or shall I use LSTM based recurrent neural network? Which shall I prefer most?
Geez,
Right,
Ijas,
sir. Ijaz, yes, sir.
Ijas. That's what. So I don't know about the Urdu character, but if you are talking with respect to text,
Right, sir.
definitely you can
Right,
go
sir.
it for RNN network. So
Okay.
my suggestion is you don't fix the algorithm and then try
Right,
to
sir.
fit in for Urdu character. You just do some research, which are all the algorithms they have already done or implemented. In
Right,
that,
sir.
the shortcomings will be there. Definitely, if I am correct, you are not the first person to propose this. So many
Right, sir.
others
Right,
would
sir.
have been done. So that
Definitely, sir.
narrow gap you can plug, because that is a very unique language. So still
Right,
lot
sir.
of opportunity will be there. So that key feature vector, you just take it out where the other researcher missed. So from that point, you just search around so many other application. Because definitely it's not like what is the algorithm can be used. So even the question can be, why can't it be used? That is also a good research.
Right, sir.
Okay, so my thing is you don't fix with algorithm, but definitely first you try for RNN, recurrent neural network, in combination with LSTM. Then you search it with the CNN.
Okay, sir. Thank you so much, sir.
Thank you. Yes.
Participants, any other questions you can ask in chat box or you can ask directly by unmuting your mic.
Sir, there is a question in chat box. What is the main difference between Python and R2?
That's like I don't know. So many these questions. It's keep on posted in LinkedIn and Facebook. So it's like the person's choice. There is no inferior and superior. So it's like the difference between apple and orange. So if you like that taste, if it is seasonal, whichever the fruit you want, it will be enjoy. And ultimately, the fruit is a fruit. So that's the difference between Python and R.
Sir, good evening, sir. I'm Dr. Akshay from Sri Ishwar College of Engineering. It was a wonderful session. I'm just asking on behalf of the students, sir, to start with ML. Would like to know what are the basic tools so that they feel comfortable to realize the importance of the language and importance of the algorithms. It is something like playway method of understanding the algorithms.
Yeah, ma'am. Anyway, thank you for asking on behalf of students, because that is a nice initiative. I don't know about your curriculum, ma'am, because in VIT, right from their first semester, Python is a part of their curriculum. So they will study first semester Python, second
Yes, sir,
semester.
we do have from the first
Yeah,
semester.
so now if it is that, it's just fine. So already some 20-30% they have covered. So
Okay.
now what we can do is, so many other tutorials are available. So what is the implemented algorithm, they can use it. Because for example, if they want to take an linear regression, the linear regression code for Python is already available.
Okay.
So let them practice those algorithms, already implemented algorithms. So what you can do is, if you are having some DSP, digital signal processing, or if you are having communication paper, or because I am just belonging to ECE, just I'm just briefing it out with respect to my area. And similarly, if we are in electrical computer science, whichever the theory portion which that can be implemented or that can be taught via lab, during that you can give the task in Python, so that they will be well versed in whatever available.
Okay,
Then
sir.
accordingly they can fix it out. So definitely, if they know Python and if they can implement a basic machine learning algorithm, then they will develop further.
Okay. So my question is, is there any IDs which are already available so that they will have some visualization charts or something like that to
No,
feel the how the
so many
setup is?
IDEs are there, ma'am. So all will support Python. Most of the IDEs will support Python, and few will be Java. So if it is other non-computer science students, non-IT students, for us Python will be easier compared to Java. And of course, I'm not telling that we don't know, but few students out of their interest, they are well versed in Java also. So in most of the IDEs, the library files are available. Suppose, for example, if you take deep neural network, so the deep neural network is from the input till the output, we are having lot of steps. But in anything, even if it is in a PyCharm or Jupyter, directly you can download or we can use the libraries available. So that will give itself the visualization tool. So as a starting point, if they are using implementing the basic machine learning algorithm, through their known IDEs using Python, that will be the good starting point.
Oh, fine, sir. Thank you. And coming to the research for as a faculty, sir, I would like to know what are the recent challenges, research challenges in these domains, combining ML with IoT.
Security side, still there a lot of challenges are there, ma'am.
Okay, sir.
The cyber security, so that is also an allied part of IoT and IoT only, because whenever you are talking about the system, when it is connected via cloud, then it will become cyber security. So it is one field interest or one field problem challenges exposing the importance of the other one. So even in industrial 4.0 revolution, we are having ML, AI as well as the cyber physical system. Security also it is included. It's not like only with respect to the mobiles. When you are talking about a laptop, it will become cyber security. So in that aspect also a lot of changes are there. And still lot of scope is available in data analytics part. How we can collect the data and what are the pre-processing and how we efficiently we can use data which we have collected from IoT devices. So that is also the scope is there. So if if you could remember the last slide which I have used, I think that is the open challenges. That is with respect to how the computer resources can be saved, and then how we can use the unstructured data formats, and then for real-time and online analysis, what is the challenges we posted and how are we going to find the solution. So those are all still open issues that you can give a try.
Okay, sir. Thank you, sir.
Thank you, ma'am.
Thank you so much. Yeah, the session was overall it was really good, sir. Thank you.
Thank you, ma'am. Thank you, ma'am.
Thank you, Akshay, ma'am. Thank you.
Sir,
Thank you, sir. Thank you.
sir,
Yes. Yeah, ma'am. Yes, ma'am. Audible. Chitra, ma'am. Any questions from participants?
So one final question, sir.
Yes,
If
ma'am.
you just let us know the paper for the research challenge, it will be very much useful for us. You can even type in the chat so that we can refer it in for our future maybe.
Sankar, sir.
Done, sir. Done.
Yes. Okay, sir. Yes, sir. Yes. Thank you, sir. Thank you so much.
Thank you, ma'am.
We'll be sharing the slides, sir, if you don't mind. Okay.
Yeah,
Yeah,
I will
ma'am.
send it to them, ma'am. They will forward to you.
Yes,
I
sir.
think they will collate it together. All together, they have to submit it to AICT too.
Okay, fine, sir. Fine, sir. Thank you, sir.
Akshay, ma'am, please find out in chat box, ma'am.
Yes, sir. Yes, sir. Yes. I got it, sir.
Yeah. Oh, thank you.
hello. Good evening, sir. Good evening, sir. Good evening,
Yeah, ma'am.
Sankar,
Tell
sir.
me.
Yeah, ma'am. I can hear you, ma'am.
Yes, sir. So this is Chitra here again from Sri Ishwar College. Sir, I could like to know about data science. In what way? Because it's all about machine learning with IoT. When most of the online courses, if it is being seen that they are mostly specifying like data science with R. Is there any so specification, sir? Because they are not most of the courses which they are offering through online. Mostly it is with Python, not with R programming. So it is not with Python. Is there any specification like that, sir?
No, no, ma'am. I think
because previously one person has asked like is there any difference between Python and R? Because
yeah,
Python
ma'am.
is
So that's what, ma'am. So I'll just answer to my point. Suppose if I want to develop a course on machine learning algorithm for this application, I will develop it in Python.
okay.
So it doesn't mean that it can be implemented only in Python, or whichever the courses which you have seen or which you have gone through. If it was implemented in R, I don't think so. It will be implemented in R. So the maybe depending on the person.
Okay.
Both are. I don't know how I can answer what is the difference between Python and R. Both it will be finding it extensively used in both the values.
Okay.
Both are
Okay.
open source programming. I think that you will agree, Nama.
Yes, sir. But both are open source programming. That is
So I
what my
think,
question.
yeah.
But most of the courses they are not using Python at all. They are using only R programming. But it is also I
No,
don't know.
anyway, because see, even the data science and ML are different. Because the data science is the broad term, like multiple disciplines will be there. Machine
Okay.
learning will be fitting within the data science. So maybe in the broader aspect, so there will be more and more library features may be available in R. But I'm not voting out Python. Definitely, if you can try it in Python, will be there. It's all where we are starting, from which point we are starting. So few people would have started from Python, so they will be keep moving in it. But I am very
Okay.
sure that lot of data science sources are available even for what you call in Python itself.
Okay. Okay, sir. Okay. Thank you. Thank you so much, sir. Thank you for your valuable input.
Thank you.
Thank you, sir.
Thank you, ma'am.
Thank you, sir.
Chitra, ma'am, thank you. So, in addition to Sankar sir, because I am using R programming, ma'am,
Sir.
my research, one of my research scholars is using for predicting the data, sir, for energy demand, for that they are using.
That's what, sir. That's what I also answered. So
Yes,
ML will be fitting in data science. So
yes, of
both
course.
are different. So when we are talking about the broader sense, so there
Okay.
will be having more opportunity in R, because I don't know, because I know only the Python.
Yes,
So maybe the lot of features will be available in R.
Okay,
So
sir.
if you know Python, but don't stick with that if it is implemented in Python, it cannot be implemented in R. Not like that. So the person who started, maybe Sir would have used R, his research scholar also using the R.
Okay.
yeah, of course.
Mm.
Thank you, sir.
Thank you, sir. Thank you, both of
Thank
you,
you.
Thank
sir.
you so much.
Thank you, sir.
Participants, you have any questions? I think no other questions. Thank you so much, sir. Thank you, Shankar sir, because you have
Thank you,
spent
sir. Thank you, sir.
almost 2 hours for answering all the questions very nicely and
Thank you, sir. Thank you.
patiently, because the participants will be happy with this your what they are given. So, a lot of take-home message, I think so. Rahul sir. If there is no there, I think one question from. Okay, sir. There is no other questions, sir. Thank you so much, sir. Shankar
Thank
sir.
you, sir. Thank you.
Thanks. Thank you. Sankar sir, so can leave, sir. No problem, sir. Thank you so much, sir.
Yes, sir. Thank you, sir. Thank you.
Thank you. Thank you.
Satish sir. Rahul sir. Rahul sir.
Yes, sir. Am I audible,
Yes, sir.
sir?
Yes, sir. Yes, sir. So you can remove from all the members. Sir. Okay.
Okay, okay, sir.
Okay, sir. Kiran sir. Good afternoon, sir. Okay, sir. Because there is no issues in I think feedback link, so they will wind up this meeting, sir.
Okay, sir. Thanks, sir.
Thank you, sir.